So we need to solve this system of equations. Now, what I noticed is in the very first equation, there are no x's. So I want to go ahead and I want to number these. And I noticed there in that very first one that I don't have an x. So maybe if I could take equation 2 and 3 and get rid of the x, hey, this might go over really well. So let's do that. So I'm going to rewrite the second and third equation. So I've got x plus 2y plus z equals 17. Go ahead and put a line through there so you know those are my z's. 2x minus 3y plus 2z equals minus 1. Now we said that in the first one what we're missing is the x, so I want to get rid of the x. Now notice the signs are not the same, so I'm going to have to multiply by a negative something. So I'm going to use a negative, and then the coefficient is a 1 and a 2, so I'm going to use a negative 2 on the top. So I'm going to rewrite the top with distributing the minus 2. So I'm going to have minus 2x minus 4y minus 2z equals minus 34. I'm going to rewrite the second equation here. Now, when I add, I notice that what? The x's cancel, but oh, look at that. The z's are also going to cancel. So that's just going to leave me with minus 7y equals minus 35. I'm going to divide both sides by 7, negative 7. So y equals 5. Wow, not exactly what I expected to happen, but hey, that's great. So now if I know what y is, look at that. That first one doesn't have an x, so I can actually plug it back into 1, which is 2y minus z equals 7. So I can do 2 times 5 minus z equals 7. 10 minus z equals 7. I'm going to subtract 10 from both sides. I'm going to get minus z equals minus 3. Divide by negative 1, divide by negative 1. And I'm going to get z equals 3. Well, we're home free now, aren't we? So kind of like I did before, I'm going to use some pink boxes so I don't start losing my values. I'd hate to do that. So the only thing now I'm lacking is an x. I really kind of like equation 2 for that. So I'm going to use equation 2, which says x plus 2y plus z equals 17. We said that x, that's what we're looking for. We know y because plus 3 equals 17. So I have x plus 10 plus 3 equals 17. X plus 13 equals 17. I subtract 13 from both sides, and I get x equals 4. So again, I'm going to box that. Now, what if you actually have to write it as an ordered pair? Then I do the x, the y, and the z.